Today we are focusing on radical functions. We did see a little intro to radical functions yesterday as we had some of our fraction exponents. So just a reminder on our fraction exponents. The bottom number in your fraction is the root of your radical, and you notice that's the one that shows up out here. So whatever that is our root. And the number in the top of the fraction is the exponent on your variable, right there on the x. So being able to flip back and forth between those or kind of understand what's going on. Most importantly for things like figuring out our domain, or if we have a restriction on our domain. Now, I've kind of gotten into a, habit of when we talk about domain restrictions that I've tick off our 3 domain restriction types: fraction, radical, radical in the bottom of the fraction. But when I say radical, we have to understand that I'm talking about like a square root specifically, but also any even root. So just a good time to remind ourselves that if it is a even root, most often we see a square root, but that could also be like a 4th root or a 6th root. Anything even has a domain restriction. And remember that that domain restriction says that what's underneath our radical needs to be greater than or equal to 0. With that being said, if we have an odd root, we don't have a domain restriction. So today we're going to see some that have odd roots. Could be like a cube root is probably the one we see most often, but anything odd, 5th root, 7th root, anything odd, there is no domain restriction. So if we have an odd root, no domain restriction means, again, our domain goes to unrestricted or negative infinity to infinity. So when we see our picture, understanding what we should be looking at, sometimes our calculators have a little bit of trouble drawing some things. But if it's an odd root, that's a continuous function from negative infinity to infinity because there's no restriction on our domain. Okay. Part of today is also a getting to know our calculator day. So make sure that as I'm typing this in, I'll put my calculator up here and that you are getting the same thing on your calculator. And if not, I can come around and help you. The first one is definitely going to take us a little bit of time to make sure that we can all get on the same page here. Let me zoom in a little bit. You're going to do 1/2 5th root of 3x minus 4. So let me talk you through how to type a 5th root into our calculator, especially if we have a number sitting out front of that. Okay. It's going to take a little bit of per calculator moment here, but we would start with typing in our fraction. Let me grab my calculator. Okay. I'm going to go type in my calculator, or in my fraction. You guys type in your fraction however you need to type in your fraction. So I'm going to do my 1/2. Okay. Then next to my 1/2, I'm going to do a 5th root. When we do something other than a square or a cube root where we have to do something like a 4th, 5th, 6th, whatever root, you're going to type that number in first. So I'm doing a 5th root. So notice right now I have 1/2, which was the number sitting in front of it, and the 5 for the 5th root. And once we have that typed in, and if you have to use the divide bar for your 1/2, put that in parentheses and then follow the parentheses with your 5. I'm going to go get my 5th root option, which is under your math menu. So hit my math button, and you're going to notice on option 5 it says x root. That allows us to do any root that we want, and in this case we want a 5th root. Some of your calculators will be like mine. When I select that option, it's going to take the number that I have currently typed and put it up where the x is, like that. Okay. Some of you, it will leave it sitting next to it, and yours will look something potentially like this. Maybe you have to type in the 1/2 with the divide, you type in the 5, and then it's got that x root sitting next to it. Okay. Now, if this is you, if you have this, you're probably also a person that has to use parentheses. When you type in the rest of that, make sure you put it in parentheses or it will not graph like you think it's supposed to. So what was the rest of it? 3x minus 4, something like that? Yeah, 3x minus 4. So put that 3x minus 4, if this is you, in parentheses so that your calculator knows that that entire expression is underneath your radical. I can just type mine in here. 3x minus 4 Now make sure yours looks something like this. If you do not put the parentheses around that, if you don't tell your calculator that the 3x minus 4 is supposed to be inside the radical, it's going to look more like a straight line. Okay, so if it doesn't look like a little curve right there, if you're having trouble with that, let me know. Now, the reason I talked about that, the fact that I know that this one is continuous, is if you look closely at mine, and maybe it looks like this on yours, it sometimes has a little pixel issue drawing all that in. It kind of looks like mine has a little hole or a break right here. I don't know if you can tell it from that far away. Right where it's crossing the x-axis. It doesn't. I know it doesn't because there's no domain restriction. All of the x's work in this. There's no break in this graph. Okay, so I'm going to draw this picture. It crosses my x-axis a little above -1. It crosses my y-axis. It crosses my x-axis somewhere between 1 and 2. So I would go draw that in this picture. Something like that. So again, the domain part of this, so not talking through our properties here. The domain part of this, we don't have a restriction. It's not an even root. So if there's no restriction on this, our domain is everything, -infinity to infinity. Now, deceiving in our looks, but it does continue to head down forever and up forever. It's just really slow. So our range is also everything, -infinity to infinity. We're going to take a moment and remind ourselves of the calculator functions that go find our x-intercept and our y-intercept for us, because we're just going to use our calculator at this point to find those. Your x-intercept, remember, is your 0 function under your calc menu. And your y-intercept is that trace 0 enter. So if you have forgotten how to find that, go ahead and put your eyes up on the board here. As I go find, let's go find our x-intercept. X-intercept is your 0. So I go to my second calc. Pick that 0 option. It's going to put that little bug on my picture. It crosses my x-axis right here, so I'm going to put my bug a little bit to the left, hit enter, put my bug a little bit to the right, hit enter, enter to skip guess, and it tells me that my equation is crossing the x-axis at 1.3, 1 1/3. Note sheet is up in the tray back there. Okay. My y-intercept, again, if you have forgotten the buttons that we push for that, go ahead and put your eyes up on the board here, and the buttons I push to find my y-intercept, trace, 0, enter, tells me that it hits my y-axis at -0.7. Just kind of reminding ourselves of those properties or those options on our calculator. Continuity. Remember that continuity is going to be tied to our domain. We don't have a break in our domain. Our function is continuous, right? So it is continuous on the entire domain, -infinity to infinity. Extrema, hills or valleys. I don't have any hilltops. I don't have any valleys. There is no extrema in this type of function. Because I don't have any breaks, because I don't have any maxes or mins, we only have one function or one interval to put under increasing or decreasing. It's doing the same thing the whole time. In this case, it is, as I go from left to right, going uphill. Slowly, but it's going uphill. So it would be increasing the entire time, never decreasing. The looks on this one are deceiving for end behavior because it is going so slow. But as we go to the left, this is going to continue to head down forever. And as we go to the right, it's going to continue to head up forever. Why is it going so slow? Because every number that I am putting in there, I'm taking the 5th root of it. Well, that's a really small number. Okay, so that's why it's going so slow. But it is headed towards -infinity on the left and up to +infinity on the right. So the 5th root is what we needed to get out of there. One of the things I expect that we know by the end of this is how to use our calculator. We all know where that 5th root is now, how to find our zeros and our y-intercepts, right? All right, the next two, definitely take some notes on the how do we find the domain and range. These are a little bit different on this one. The calculator part, not as challenging. It's the algebra behind our domain and range. So 2 plus square root of 5x minus 14 is our function. Let's go graph that. Remember where your square root is, on the left-hand side above your x squared. This is an even root, right? A square root. So doesn't it make sense that my graph has a domain restriction, that it's only part of a function, or it doesn't quite go all the way across my graph? That's true. It has a domain restriction. So it looks like it starts kind of over here at about 3, 2-ish. We're going to figure out exactly what that is here in just a second. So I would just draw that approximate graph here. The one thing your calculator can't find on this is your domain and range. So that's where, when we are asked to identify our domain and range, it is going to be exact, but we have to rely on our algebra and what we know about restrictions on functions. So domain, this has a domain restriction, right? It is a radical, and the restriction on a radical has to be greater than or equal to 0. That's where our domain comes from. So I take what's underneath my radical, and I set it greater than or equal to 0. Solve for x. At this point, this turns out to be a nice number. I don't really care how you write this, 14/5, 2 4/5, 2.8. It's all the same thing, and we didn't have to round, so I don't care which way you write that. But we write the interval that represents that. Greater than or equal to 2 4/5 would look like 2 4/5, comma, infinity. And we do actually include it because of the or equal to, so I would put a bracket at the 2 4/5 or the 2.8. Okay. The domain part of it, not so bad. We tend to remember that one because we've been using that rule a lot. Radical, greater than or equal to 0. It's the range part. Every time we go to do a range on one of these problems, you're going to plug back in that domain you just got. Okay, so we just got 2 4/5, plug it back in. So whatever number you just got, we're basically figuring out the other part of this ordered pair. So where is our range starting? Plug in 2 4/5. So our function 2 plus the square root of 5 times 2 4/5 minus 14. Now that's kind of ugly, so I could grab my calculator, but if you remember where we got 2 4/5, it was from solving that radical when I set it equal to 0. So hopefully it'll make sense that when I plug that in, we are going to get 0 here underneath the radical, right? Isn't that where we got 2 4/5 anyway, setting it equal to 0? So when I plug it back in, this is going to go to 0, and we get then 2 plus the square root of 0, which is just 2. So the other part of this ordered pair is 2 4/5, comma 2. Our range is our y's, starts at 2 and heads up, and up is infinity. All right, go to your calculator. Oh, go to our calculator. We don't need to go to our calculator. Does it hit our x or y axis? No, so we don't have those. Move on. Okay, continuity. This one's always a little bit of a weird one. But once I start drawing that picture, do I have to pick up my pencil? No. So it is continuous, but only on the domain. So we just, again, match your domain to your continuity. So if that doesn't have a break, it is continuous. It's when this one has like 2 intervals up here that we have to talk about the discontinuity happening. But it's continuous on the domain. So from 2 4/5 to infinity, that graph would be continuous. Now, I'm going to pause there real quick, and I don't know if this caught anyone or not, but sometimes it bothers people that I didn't use a bracket there. And up above I did, okay? The only time that brackets and parentheses mean something or are important are on domain and range. Now, bring that down to continuity. If I put a bracket here, would I be wrong? No, you just don't need it, Okay, it doesn't matter whether you include that point or don't include that point, but it's only important on domain and range. So if you just match it identically, that's fine. You can put a bracket under continuity. It's not wrong. Okay. Extrema, again, we talked about this yesterday. That's not the bottom of a valley. It looks like a low point, but it's not the bottom of a valley. So we wouldn't actually include it as an extrema on this. This one is increasing the entire time. So on our domain, again, that whole bracket versus parentheses convo applies to this as well. On our domain, it is increasing, never decreasing. Talked about this again yesterday. The end behavior to the left. Our graph doesn't go to the left, right? So because it doesn't continue to the left, we don't have end behavior towards negative infinity. It doesn't go to negative infinity. It does go to the right. And as we go to the right, this is going to continue to increase or go up towards positive infinity. Any questions on that? All right. The last one, the algebra on this one, we won't see it super often, but you'll want a reminder. So take good notes for yourself, again, on the domain and range part. The rest of it is no different than anything we've done before. But the domain and range is a little tricky to remember where to find these weird-looking numbers that we're about to get, because our calculator won't do it for us. Okay? And this happens when you have two radicals. So every problem that you run into that has two radicals, you're going to come back to this example in your notes to remind yourself how you did the domain and range. So first of all, just go grab your calculator, type that into your y equals. Use the picture to help you get a good window on this one. If you notice, our picture is kind of adjusted off to the side here because it kind of runs off your picture. And all of your ones that have two radicals are going to look very similar to this one. Okay, so you're going to want to adjust until you can see the whole little squiggle that's going to happen here. You should be getting a picture that looks something like this. Did we all get it typed in correctly? Okay, so again, this is going to be a weird one, kind of unique. Every time we run into two radicals, it's going to resemble something like this, a little squiggle that starts and stops. And a lot of times when I tell us that it looks like our picture stops, it didn't actually. This one actually stops because of the two pieces that make up this function, which is two radicals, the two domain restrictions that we're going to see. Okay, so I'm going to draw this squiggle, starts up at about 3, somewhere around 1, kind of crosses through my x-axis somewhere about, I don't know, 4-ish, and then stops down here. That's over at like 15 down a ways there. So drawing that picture in here somehow-ish goes something like that. Okay. Well, the next step that we're going to do is our algebra. It was basically we're going to find that point for ourselves, that ordered pair, and we're going to find that ordered pair because the x's and y's of those ordered pairs tell us our domain, x to x, and our range, y to y. So as long as we can find those 2 points, we can find our domain and range. So how do I find those? Start your domain just like we did the last one. It's made up of radicals, and radicals have a restriction that say it has to be greater than or equal to 0, but we have 2 of them this time. So I just do each one individually. 15 minus x has to be greater than or equal to 0, and 4x minus 4 has to be greater than or equal to 0. When you're solving the 15 minus x has to be greater than or equal to 0, just a reminder, because a lot of times when we solve this one, people will go in this order. Subtract the 15 and then divide by the -1. Remind me what happens on an inequality when we divide by a -1. Our sign flips, right? Anytime it's that negative with a multiplication or a division, it doesn't matter which way you go there, that sign is going to flip, so it's going to actually become less than. X is less than 15. So we flipped our sign because of the dividing by a negative. Okay. On the other side, again, just solve for x. And we get x is greater than or equal to 1. Okay, so those match my picture. This would be an x value of 1. This would be an x value of 15, and that's your domain. Farthest left would be 1, farthest right would be 15. Make sure you write it in the order of small number, comma, big number. And it is an or equal to, so we do use brackets on each side of those. So it can equal 1 and it can equal 15. The second part of it, if you don't put notes for yourself, you're going to totally forget where these weird looking numbers come from. But it's just like we did on the last one. To find the range, you just have to plug the x's back in. I'm going to erase this because I'm out of room to do my algebra here. Does anyone still need it? Okay, so let's go ahead and erase here. And we just have to plug in both. So the first time I'm going to plug in 1, because that's what I got here. So when I plug in 1, it'll tell me the y value for that. Now, as I plug these in, you're going to notice each time I do this that one of my radicals is going to equal 0. Well, it should, because that's where I'm getting that x value from. In the first time, it's the second one. 4 minus 4 is 0. Okay, so we end up with just the first one, which would be 15 minus 1, or 14. You don't have to simplify and don't get it as a decimal, just leave it as is. Okay, square root of 14. So that would be this number right here, square root of 14. The other range value we're going to get, the other y value we're going to get, we get from plugging in the 15. Okay, so again, go back to my functions, plug in 15. We'll notice that that first one, 15 minus 15, is 0. Don't lose that little negative sitting out front. Okay, there is a negative out front of that radical. Negative square root of 4 times 15 is 60. Minus 4 is 56. And again, guys, I don't need you to worry about simplifying that. If you do, that's great. I don't mind, but we don't have to do any work here. Okay, square root of 56, just leave it as is. It's the negative square root of 56. Okay. Range, lowest point up to highest point for our y values. Negative square root of 56, comma, square root of 14, again with brackets because it actually does hit at those points. After those two parts of this, domain and range, the rest, again, very simple. Calculator will tell us our x-intercept, that's our 0. So grab your calculator, go get our 0 function here, put my bug a little bit left. A little bit right. Enter to skip guess. It's at 3.8. It does not hit our y-axis in this problem, so there isn't a y-intercept. There can be, there just isn't on this one. It is continuous. I can trace that whole picture without picking up my pencil, but it's only continuous on the domain. No maxes or mins because there's no hills or valleys. In this one, as I trace the entire time, my pencil is headed down, so it is never increasing, decreasing the entire time from 1 to 15 on the domain. Does not continue to the left, does not continue to the right, so no end behavior to talk about. Any questions on that? All right. The last part of today is review from Algebra 2. How do we solve radical equations? Okay. Good review, because I noticed that sometimes when we've been doing this in the past, our order of operations has kind of caught us a little bit. So maybe looking at it in a different way. If I were to ask you to look at the right-hand side of this function, just that part of it, are there any outside numbers? Yes. If there are outside numbers, you cannot get rid of your radical yet. Okay, there can't be outside numbers to be able to get rid of a radical. So your job number 1 is to deal with any outside numbers before dealing with the radical. So the first thing I would do on this problem is add 3 to both sides. Once we don't have any outside numbers anymore, then I can deal with the fact that there's a square root over there. Okay, and the opposite of my square root would be to square. Be careful that you actually use what that root is when you do its opposite, right? Squaring and square rooting, cubing and cube rooting, right? So those are opposites of each other. I get the 28x plus 29 on the right-hand side. But over here, if I have a binomial, remember that means I need to FOIL. So I'm going to write it twice. and FOIL that to get the left-hand side. 6x plus 6x will give us 12x. All right. At this point, I have x squareds, x's, plain numbers, and if that's the case, we have to get everything onto the same side and either factor or quadratic formula, or completing the square if you are really into completing the square, to solve for x. So I would always move it so that my x squared term is positive. It'll be a lot easier to solve that way. So I just pick my side based on what's going to make my x squared positive. So I'm going to move to the left-hand side here. Subtract the 28x. Subtract 29. That has a GCF, which will make it easier to factor if I take out that GCF. Keep factoring to solve for x. Factors of -5 that add up to -4 would be -5 and +1. At this point, remember, anything that has an x gets set equal to 0. Well, our GCF does not. So in this problem, our GCF does not get set equal to 0, just to the x's. And we end up with x equals 5 and x equals -1. Questions on that? Last year, when you did solving radical equations, you were probably introduced to this next phrase, which is what we would actually probably do here before we circle our answers. We don't need to on this one, I'm telling you they work, but you would be prompted to in the directions to check for extraneous solutions. Guys, I don't really need you to remember what that means other than the fact that it means check your answers. They don't all work. Okay, that's all it's saying to do. So when you see that at the end of the directions in a section that's asking you to solve a radical equation, it's going to say check for extraneous solutions. Check your answers. Plug them back in and make sure they work. Okay, that's all that means, because they're not all going to work. So we're going to go ahead. I'm going to skip this example. Let's go ahead and go to this one. Square root of 5x minus 40 equals -10. We're going to see a couple problems here that have extraneous solutions and what we do when we run into one of those and how we find one when we run into one of those. Okay, so solving this, again, to start the problem, I asked myself, where the radical is, are there any outside numbers? No. There are no outside numbers, so I can just jump straight into getting rid of my radical, do the opposite of square rooting, and square both sides. Okay. When I square and square root, they are opposites of each other. I just get what's underneath. 5x minus 40 equals 100. Solve for x. Let's see, 140 divided by 5 would be 228. Okay, and now we know the end of my directions are going to say check for extraneous solutions. And what that means to me is plug it back in and make sure that it works. Okay, so I test x equals 28. And all that means is I put it back into the equation. And I make sure that when I clean this up, that both sides of my equation equal the same number. Well, this one is a whole nother mathematical conversation, but 5 times 28, 140, minus 40 would be the square root of 100, and the square root of 100 is 10. Does 10 equal -10? No. Now, that means I would come back over here and throw out the one answer I had. If I throw out all answers that I had one and I threw it out, what is our answer? No solution. Okay. Your answer will never be extraneous. In fact, you don't ever even have to write that word. It just, again, is to remind you to check your answers. Now, just in case there's somebody out there wondering, wait, I thought when we square rooted, don't we get the plus or minus? So couldn't that equal -10? I don't know if that was a thought in anyone's head. And that is true, but that only happens if we are the ones that insert the radical into the problem. And that happens when we have an equation such as like an x squared equals 25, and to solve it, we square root both sides. Notice I'm the one that square rooted, right? And so when I do that, that's when it has to be plus or minus, because those are x's that can go in here. If the square root starts in our problem, we use what's called the principal value. And the principal value is whatever sign is there. So if it's a positive square root, my answer is a positive number. If they had put a negative here, we would have a negative answer there. Questions on that? Okay. I have one more for us to look at here. 2x equals 6 plus square root of 20. Ooh, before we do that, can we back up here real quick? Did anyone look at this problem and know that it was going to be no solution before we started? Maybe. Now, can you look at this problem and see why it would be a no solution before we start? Is it acceptable to see that and say no solution? 100%. Okay, you absolutely can look at this and say that a radical can never equal a negative number. True. That is a true statement. A radical itself can never equal a negative number. And if you saw that at the beginning, you are absolutely welcome to stop and say no solution and don't do any work. Because there's no number that's going to make this radical equal a negative number. You don't have to, because if we follow our process, it'll tell us that. But you would be welcome, in case you saw that, you would be welcome to do that, okay? All right, now to our last one. Again, we start by, to solve these, do we have any outside numbers? Yes. How do I get rid of that outside number? Subtract. So the first thing I'm going to do is subtract the 6 over. And I know the solving part of it, maybe we didn't need that help, but sometimes we forget how to get this by itself. All right. Now my radical is by itself. I would square both sides. And again, if I square a binomial, I must FOIL. Write it twice and FOIL. So that will give me 4x squared. Negative 12 plus negative 12 would be negative 24x plus 36. And again, I get to the point where I have x's, x squareds, and plain numbers. And that tells me I have to get everything to the same side and either factor, quadratic formula, completing the square to solve for x. So as I'm doing this, I would move everything to the left so that my x squared is positive. So subtract 20x. And then when I go to subtract the 36, notice that that cancels also. And that's okay. We just get negative 4x squared minus 44x equals 0. And this is where remembering step number 1 of factoring is going to save us. Step number 1, look for a GCF. This has a GCF, right? This has a GCF. 4 and 44 both have 4 in common, and they both have an x. So your GCF is 4x. And this time, I do set my GCF equal to 0 because it has an x. Everything that has an x gets set equal to 0. When I solve that, though, remember that dividing by 4, 0 divided by 4 is still just 0, right? So we get 0 for one of our possible answers, and we get 11 for our other possible answer. And again, I'm saying possible answers because our directions are going to say check for extraneous solutions. Fancy math phrase for plug your answers in and make sure they work. Okay, so then we come over here and we just test those out. So I'm going to test x equals 0. Plug it into my equation and make sure both sides are equal. Two times 0 is 0. Let's see, 20 times 0 is 0 plus 36 is 36. The square root of 36 is 6, plus 6 is 12. Does 0 equal 12? No, not a trick question. 0 does not equal 12, right? That does not actually work in this radical equation. So I throw out 0. Your two answers are completely unrelated. You might end up throwing out both. You might end up keeping both. You can throw out one and keep the other, which is why we will always have to test each one individually. So then I test x equals 11. Again, because of the phrase, check for extraneous solutions. I plug in 11. Okay, 2 times 11 is 22. 20 times 11 would be 220, plus 36 would be 256. And the square root of 256, 16. Okay, well, 6 plus 16 is 22. That is a true statement. 22 does equal 22. That works. Oops, 11. That's 11. X does equal 11. So that's just your example. Those answers, no relation to each other. They can both work. They can both not work. You always have to test every number that you get at the end individually. Your assignment tonight is out of the book, and part of it does include graphing. So I will give you graph paper. You are welcome to do your entire assignment on the graph paper if you would like, or not.